What time is it? It's BioTime! So for today's video, we will be talking about circulatory system. So as we all know, circulatory system is a network consisting of blood, the blood vessels, and the heart. So this system supplies tissues in the body with oxygen and other nutrients, and it also removes waste products such as the carbon dioxide. So we have here a picture of a blood vessel network from the heart and back to it. The blood circulation is categorized into two parts. The first part is the systemic circulation, wherein oxygenated blood from the left ventricle is carried through the arteries to the capillaries in the different tissues. From the tissue capillaries, the deoxygenated blood returns through a system of veins to the right atrium of the heart. Then proceeding to the next type of circulation, which is the pulmonary circulation, wherein the oxygenated blood is carried from the right ventricle to the lungs and back to the left atrium and the left ventricle of the heart. During blood circulation, blood pressure decreases with the distance from the heart. It means that blood moves from higher pressure to lower pressure, starting with the pumping of the blood from the heart to the arteries, meaning the arteries have higher blood pressure compared to the veins. If we rank the components of blood pressure throughout specific blood vessels, we can see in the graph that the aorta has the highest blood pressure, and it is followed by the elastic arteries, muscular arteries, arterioles, capillaries, venules, medium and large veins, and lastly, the vena cava. We can also see in the graph the systolic and diastolic pressure of blood within the different types of blood vessels. Systolic pressure reflects the contraction of the ventricles, while the diastolic pressure is when ventricles relax. The reason why veins also have lesser blood pressure compared to that of the arteries, and they can hold more blood volume, is because unlike the arteries, which receive blood right after the heart contraction, veins also have lesser contractile capacity and have thinner walls compared to that of the arteries. Moving on, the equation of blood pressure in blood vessels is analogous to that of the Ohm's law, which is P equals Q times R. P as a pressure, Q as a flow, and R as a resistance. This means that blood pressure is directly proportional to that of the blood flow and the blood resistance. The blood flow and blood resistance are affected by several factors, namely the heart rate, blood volume, and the blood vessel diameter. Higher heart rate creates faster blood flow. As blood volume increases, blood flow also increases. When blood vessels decrease in diameter, the resistance increases, resulting to lesser blood flow. When these circumstances are met, we expect a higher blood pressure in a person. Blood pressure is regulated by several hormones. These are the ADH, angiotensin, aldosterone, ANP, and the epinephrine. So the first hormone is the antidiuretic hormone, or the ADH. It is also called vasopressin, which comes from the hypothalamus, and its receptors are chemoreceptors or the osmoreceptors. It takes effect in kidneys collecting duct to promote water absorption, resulting to increased blood volume and blood pressure. So our second hormone is the angiotensin. It is created when renin breaks down angiotensinogen in the liver. Its receptors are the angiotensin receptors, and it takes effect in the kidneys and adrenal glands. It constricts blood vessels, decreasing its diameter, resulting to increased blood pressure. So our third hormone is the aldosterone, which is created in the adrenal cortex and binds to mineralocorticoid receptors in kidneys and colon that promotes watery absorption along with sodium, increasing the blood volume and blood pressure. Our fourth hormone is the epinephrine, or simply the adrenaline, which is produced by the adrenal medulla that binds to alpha and beta receptors in the muscles and blood vessels. During stress, epinephrine is released to constrict the blood vessel diameter and increases the heart rate, resulting to increased blood pressure. And lastly, our fifth hormone is the atrial natriuretic peptide, or the ANP, created in the heart atrium and binds to atrial volume receptors in the adrenal glands. It acts as vasodilator and controls electrolyte homeostasis, which decreases the blood pressure. All these hormones are important in blood pressure regulation. But why really is it important to regulate our blood pressure? It is important because we need to carry the right amount of oxygen and nutrients to the different tissues of our body and efficiently remove the waste products while doing certain activities. So when a blood pressure of a person is lower than normal, he has a hypotension, and fainting could happen, wherein there is a temporary loss of blood supply to the brain. On the other hand, when a person has a higher blood pressure than normal, also termed as hypertension, the circulatory system and the other organs may be severely damaged. So if you don't want to have hypotension and hypertension, we'll better maintain a healthy diet and exercise daily. So that is all for our video today. Thank you for watching.